In the previous episode, we developed a technique to construct a smooth interpolation between two functions, which was roughly described as smoothly turning off the left function f and turning on the right function g in the interval of transition. However, in order for this method to work, there was an implicit assumption that we had to make, which is that both f and g had to be smooth in the interval of transition. But what if that was not the case? For example, if f is equal to 1 over x, or g is equal to sine of 1 over x, then our method that we came up with breaks apart since at least one function is not smoothly defined for all values in the interval of transition. Can we somehow fix this problem? Last time, we were a bit too informal with the statement of the original problem, so let's restate the problem to be more well defined. F is a smooth function from negative infinity to a, and g is a smooth function from b to infinity. Then can we find the smooth function h such that h equals f on the left section and h equals g on the right section? So, f and g are technically not defined beyond their respective left and right region. So, what if either or both f and g can be naturally extended past the left and the right boundary a little bit, but not for the full domain of transition? And what do I mean by a natural extension? The function given by its prescribed definition, for example 1 over x for the left function, can be extended to the domain of transition with the same formula. For example, the left function 1 over x can be extended smoothly up to some number less than 0, and similarly for the right function up to some number greater than 0. Then, we can define any smooth function in the domain of transition -1 to 1 and smoothly interpolate two separate times. This function, in fact, is smooth in the mathematical sense of the definition of the word smooth, which means infinitely differentiable. However, it has a little too many kinks and I don't particularly find it aesthetically pleasing. So, maybe instead if we use the middle function to be some higher order Hermite interpolating polynomial, then the end result comes out much nicer. So, what if either or both function cannot be naturally extended beyond its left and right boundary? For example, if we try to extend these functions using its original definition, then it loses smoothness somehow. So we gotta come up with a way to artificially extend the function. Since we know the function values and their derivatives of all orders for both functions at each of their respective boundaries, we can use the power series to extend the left and the right function, and use that to interpolate between the left and the right boundary smoothly. And in case the power series extension only extends so far, we can use the first and the second method together.